Now I did. Want to make sure we get this lecture up on YouTube. Speaking of that, all of our lectures are on Blackboard, by the way. So let's try another one here. And this, oh, I didn't give you time to write this down. Write this down, and then we're going to do one together. All right? So I'll wait like a minute so you can write this down. Okay, we good? All right, so next problem. 4 over 7 times 5 over 8. I'm going to just speed up a little bit. First thing we want to do is simplify. That 4 is 2 times 2. The 7 doesn't change. The second fraction. 5 is a prime number. It doesn't break down. Now that 8 is really 2 times 2 times 2. Does that make sense, everyone? Okay, now I like to take the one extra step. I will write one big numerator and one big denominator with everything in order. Now I simplify. I look for things that are the same on the top and bottom. So I have 2 over 2. They reduce. Another 2 over 2 reduces. And there is nothing else I can reduce. So now these are the leftovers. In the numerator, I only have a 5. In my denominator, 2 times 7 is 14. And I know this is completely reduced. And how do I know that? Is because we reduced it at the very start of the problem. Does that make sense, everyone? Do you see why we like to prime factorize first and then multiply? Todd, it looks like you have a question.
No, I don't have a question. I was gonna say I understand.
Okay, good. All right. Are there any other questions? Okay, I'm gonna give you one to do now. This one, a little bit more intense. This is all you because I gotta be honest, I'm gonna go grab a drink of water. So we got negative 14 over 15 times positive 20 over 21. Are there any questions? Did anybody get an answer? How about that?
Is it -8/9?
Oh. Who said that?
Maria.
Oh, good job, Maria. You nailed it. Good job. All right, let's see how to do this if we're stumped, okay? So, first off, that negative symbol. That. Guess my dog got into something. Did you guys hear Molly yell in the background? So this negative sign is just going to come along for the ride. That's it. So I put a negative here, and I'm going to break down everything. 14 is really 2 times 7. 15 is 3 times 5. Now let's do the 20. 20 is 2 times 2 times 5. Is that correct?
Yeah.
And then 21 is 3 times 7. So notice I didn't do any multiplying or anything yet. I just broke numbers down. So now I'll write one big numerator and one big denominator in order. 2 times 2 times 2 times 5 times 7. 1, 2, 3. Yep. And then my denominator is going to be
3 times 5, 3.
3 times 3 times 5 times 7. So now I'm looking for numbers that are the same on the top and bottom. If they're the same, I can reduce them to a number 1. So 5 over 5 reduces. 7 over 7 reduces. And that's it. We multiply the leftovers. 2 times 2 times 2 is 8. And 3 times 3 is 9. How are we looking? Pretty good? All right. Connor, you have a question?
I do. So when I was figuring it out, the first two numbers on the top, you have to, like how it is here with 2 times 7, you have to write in the parentheses like what it equals. That's what I was having trouble on, like looking at, but because I was doing -14 and then 15 first, not 20 and 21. Like that's what I was getting confused on was, how to write like how it is here with 2 times 7, 3 times 5.
Yeah, I do. So it doesn't. I like to stick to one fraction at a time. So I did the 14 first, and then the 15, and then I went ahead and did the second fraction.
Okay.
It doesn't matter the order in which you do it. What matters is you're writing them down correctly in their same spots. So personally, I like to start with the first fraction, and then I will do the second fraction. Does that make
Okay.
sense?
Mm-hmm.
Okay.
Thank you.
Mm-hmm. No problem. All right, let's do another one. Do you want to do this together or do you want to do it separately? Maria Resch, you get to pick. Together or separately?
Separately?
Good, I like that attitude. Go for it.
one's ready.
All right. All right. So we know Todd got an answer. Todd, what'd you get?
I got positive 4 over 21.
Anybody else get 4 over 21?
I guess 4/7.
4 over 7, okay. Robert, you said you got 4 over 21? All right, so let's go ahead. Let's go through it.
Oh, 3.
Oh, wait a minute. You fixing it, Asthma.
Yeah, I did not say the 3 times 7. Sorry.
That's okay. So I guess Asthma got 4 over 21 as well. So I think the answer is 4 over 21, Todd. Let's just verify it. We're going to break down every single fraction here. So let me put a negative and a negative out front. So this is just a setup. That looks really bad. There we go. That makes me feel better. All right. 10. 2 times 5. 28. 2 times 2 times 7. Is that correct? All right. 8. 2 times 2 times 2. And then 15 is 3 times 5. So now I'm going to write one big fraction with one big numerator and one big denominator. However, what's a negative times a negative?
Positive.
Yeah, it's a positive. So the negative and the negative are going to cancel each other out. So I'm just going to write one big numerator. How many 2's? 4 of them. And then my denominator is 2 times 2 times 3 times 5 times 7. Good. Now here's my favorite part. It's reducing time. The 2's reduce. They reduce. All right, no more 2's. The 5's reduce. So I'm left over with, in the numerator, 2 times 2 is 4.
31.
My denominator, 3 times 7 is 21. Okay, serious question. Multiplying fractions. How are we feeling about it?
Good.
Pretty good, pretty straightforward. It's very straightforward. All right. So now I'm going to throw you a curveball.
I'm having a little bit of trouble like reducing the numbers. I keep reducing them the wrong way.
Are you doing what we're doing, or are you trying to do it in your head?
Both.
Okay, don't do it in your head. All right? Write them out. Now, if you're writing them out like us, Zach, the problem you may be having is the prime factorization part. So, like, for example, 28, what I do is I will write it, and then I draw two little branches. And I think to myself, two numbers that multiply to get 28. I don't care what they are. Just give me two numbers that multiply to get 28. How about 2 and 14? Now, the 2 is a prime number, so I circle it. The 14, I can break down even further into 2 times 7. 2 is a prime number, and 7 is a prime number. So that's how I got 28 to equal 2 times 2 times 7. So to highlight it so you can see it, those two blue highlighters, that's 28. I just rewrote it as something different. Does that make sense?
Yeah, okay, I got it. I think I got it.
Yes. So I do that for every single number that's not prime. All right. Here's the curveball. I gotta find a good one. Yeah, this one will probably be good. Two over 3 divided by 5 over 6. What's the curveball here, Todd? What's the curveball? What looks different from this problem compared to all the other ones? Anybody?
Division.
Yeah, we're dividing. So let me give you the steps for division. Step 1, rewrite the first fraction. Step 2, change the division symbol into a multiplication symbol. Step 3, write the, and this is a real big fancy math word that we're going to do right here. Write the reciprocal of the second fraction. All right, now that word reciprocal is a really fancy math word for flip. Just flip the fraction upside down. And the last step, follow rules for multiplying fractions. So in other words, all you got to do is just rewrite the problem as a multiplication problem, and then you just turn it into a multiplication problem. So if I follow these steps and I write them out above, 2 over 3 divided by 5 over 6. Step 1, rewrite the first fraction. Rewrite that prettier. Step 2, change that division symbol into a multiplication symbol. Step 3, write the reciprocal of the second fraction. 5 over 6 turns into 6 over 5. Now, I follow the rules for multiplying. So that 2 is prime, it stays the same. The 3 is prime, it stays the same. That 6 is 2 times 3. And the 5 is prime, it stays the same. So, if I wanted to, I can write one big numerator and one big denominator. And I will reduce the same number that I see on the top and bottom. So, the only number I can reduce is the 3. I write what's ever left over. 2 times 2 is 4. And a 5 in my denominator. And that's it. So, 2/3 divided by 5/6 is 4 over 5. How are we looking? Robert, dividing fractions is essentially what? Just flipping it and multiplying it. That's it. Dividing fractions, you were just flipping it and then multiplying. How we look?
Good.
All right, yeah. Like I said, I don't think this is too difficult. So let me give you one to do. I'll try to leave the steps up so you can see them. Try 3 over 4 divided by -7 over 8.
I didn't get the rest of the equation up top.
What?
Sorry.
You're okay. Here, let me do this for you, Todd. Let me put a 3 and a 3. Now, those 3s are the ones that I scratched out, so I'll highlight them so you know that's what I scratched out, okay?
Okay, I got it now.
Good. Perfect. Thank you. Yeah, if I'm moving too fast, you just got to let me know. That's all. So 3 over 4 divided by negative 7 over 8. All right, do we have an answer?
Would it be negative 6 over 7?
Sure. I didn't do the problem yet. Let's see if you're right, Robert. I'm going to write negative 6. Oh, I got the wrong marker. I'll write negative 6 over 7. Did anybody else get negative 6 over 7 like Robert?
Me too.
Perfect. All right, let's do it. First, read the problem. 3/4 divided by negative 7 over 8. I'm dividing, so I got to follow those steps. Step 1, I'm going to rewrite the first fraction. Step 2, division changes the multiplication. Step 3, I reciprocate or flip the second fraction. Notice the negative is just, it comes along for the ride. So, let's break everything down now. 3 is prime, it stays the same. 4 is 2 times 2. 8 is 2 times 2 times 2. And then the 7 is prime, so it stays the same. Now, I'm going to write one big numerator, one big denominator, and here's what I know. The first fraction was positive. The second fraction is negative, so I know my answer is going to be negative. So I'm just going to put a negative sign out front. 2 times 2 times 2 times 3. And then my denominator is going to be 2 times 2 times 7. And I'm looking for numbers that are the same on the top and bottom. 2 over 2. 2 over 2. That looks like it's it. So multiply the leftovers. 2 times 3 is 6. Over 7. I like this. I like this. What do you think, Todd?
I agree.
Straightforward. Todd, would you like another curveball?
Give it to me.
All right, here you go. Here's our next example. So, Todd, what's the curveball here?
This time we have mixed numbers.
Okay. Now, what do we know about mixed numbers? I mean, you're correct. But what do we know about them? Do we know how to multiply them yet?
No.
No. But we do know how to multiply fractions, just regular fractions, correct? Now, if we go back, and even if we look at the example above, can somebody tell me what type of fraction is this? What type of fraction? Now remember, there are 3 types of fractions. What type of fraction is that? I'm sorry, I didn't hear you.
Would it be a simplified fraction?
Not as simplified. Okay, well, it is simplified, Madeline. I'm not gonna lie on that. It is simplified, but what type of fraction is it?
Is it a proper fraction?
Very good, Robert. It's a proper fraction. What type of fraction is this?
Improper.
Improper. And we know that if the fraction is proper or improper, we can follow the technique for multiplying, correct? The problem with our situation, we have mixed numbers. So my question to you is this. Is there a way that I can take a mixed number and make it into either a proper or improper fraction? Because if I can multiply.
Don't you have to do 5 times 2, and then it'll be 10, and then 10 plus 4, which makes it 14 over 5.
Perfect. So Madeline, I guess what you're saying is, can I convert a mixed number into an improper fraction? Yes or no?
Yes.
And if I can do that, can I then multiply the fractions? Yes or no?
Yes.
Perfect. So what we're going to have to do here is we're going to have to convert both of these first. And this is what makes fractions, I think, not difficult, but they tend to get cumbersome. Because now it's like, oh, I got to remember to do all these things. All right? So the first thing we're going to do is convert. So 2 4/5 into an improper fraction. Remember, your denominator stays the same. You take your whole number times the denominator plus the numerator. So that's going to be 2 times 5, which is 10, plus 4 is 14 over 5. Now, we need to do the same exact thing here with 1 7/8, okay? So 1 7/8, remember, denominator stays the same. Then we take our whole number times the denominator plus the numerator. So 8 times 1 is 8, plus 7 is 15. So we have 15 over 8. All right. How are we looking so far? Are we all on the same page?
Yes.
Okay. So now that I've converted from mixed numbers into improper fractions, we just multiply now. So, you know me, I like to break everything down. So the 14, that's going to turn into 2 times 7. The 5 is prime, so it stays the same. The 15, that's going to be 3 times 5. The 8 is going to be 2 times 2 times 2. I write one big numerator, one big denominator. Now, I look for numbers that are the same in the top and bottom. 2 over 2 reduces. Looks like 5 over 5 reduces. And I think that's it. Is that correct, everyone? 3 times 7, we're going to multiply the leftovers. 3 times 7 is 21. 2 times 2 is 4. Now, I will give you this. I'm going to write it in red. You got to make sure you follow directions. Okay, you got to make sure you follow directions. And what I mean by that is this, okay? When you read the directions, all right? Sorry. When you read the directions, it's going to tell you how do they want the answer. If they just say write the answer as a simplified fraction, then you're good. 21 over 4 is completely fine. Okay? If the directions say write as a mixed number, Well, then what you're going to have to do is you're going to have to take 21 over 4 and then convert it back into a mixed number. And how do we convert back into a mixed number?
We see how many times 4 goes into 21.
Exactly. All we got to do is just divide. Okay? So we see how many times 4 goes into 21. So 4 goes into 21 5 times with a remainder of 1. And remember, your quotient is the whole number. Your remainder is the numerator. And then your denominator stays the same. The number out front, by the way, is called the divisor. So the divisor is your denominator. So 21 over 4 equals 5 1/4 as a mixed number. Okay? And that is it. So what I'm going to do here is I'm going to call it a day. Oh, sorry. I stopped sharing. I didn't want to do that. I wanted to stop recording.